Hello, everyone. Today we'll go over an introduction to waves. The technical definition of a wave is a disturbance that propagates through a medium. Think if you were to grab a string and stretch it and then plunk it, that disturbance will propagate through the rest of the string, which creates a wave. Now, let's go over the properties of waves. To start, waves have crests and troughs. Crests are these highest points on the wave, while the troughs are the lowest point in the oscillations. Next, the period of a wave is the time it takes to complete one full oscillation or one full cycle of motion. So this can be measured as the time taken to go from the peak to peak, or from trough to trough, or any two of the same points along a wave. The frequency is the inverse of the period. So while the period is how long it took to complete one full oscillation, the frequency is how many oscillations are completed in 1 second. We express frequency in the unit hertz, which is equal to 1 divided by seconds. Next, the amplitude of a wave is the maximum displacement from the wave's equilibrium position. Think of this as the scale of how large the wave oscillations are. If you were to measure the magnitude of the oscillation from the peak to the trough, the amplitude would be half of that size because it's defined as the displacement from the equilibrium position, and the equilibrium position is in the middle of the wave. So think of it as the size of the magnitude of the crest to the halfway point, or the trough to the halfway point. Moving on, angular frequency and wave equations. The angular frequency is the rate of angular displacement of a wave. If you were to think back to the unit circle from math class, the angular frequency measures how many radians per second the wave oscillates at. It's given by the formula 2 pi times the frequency. Next, the wave equation mathematically describes the wave. This puts together all the components we had talked about, where A is the amplitude, omega is the angular frequency, and x is its position along the x-axis on a graph. Usually this will be time when you work in problems. Now let's talk about the different kinds of waves. The two kinds of waves are transverse and longitudinal. Starting with transverse waves, these waves travel in a direction and the oscillations are perpendicular to the direction of motion. These are probably like the standard wave you would think of when you think of a wave, and an example is waves on water, like say in the ocean. Waves are created by a disturbance, and they oscillate vertically while the motion travels horizontally, so the oscillations are perpendicular to the plane of motion. Lastly, we have longitudinal waves. These are waves that have their oscillations in the same direction that the wave is traveling in. So, looking at the drawing of this longitudinal wave, the oscillations are occurring in the same direction that the wave is traveling in. So, you'll see there's areas where it gets compressed and then decompressed. So, for an example, sound waves are longitudinal waves. Or you can think of if you're to lay out a slinky on the floor horizontally and push it horizontally, the wave will not oscillate up and down. Instead, it would horizontally oscillate all the way to the other end of the slinky, having areas of compression and decompression. And that's what a longitudinal wave is.